So today we're going to continue with our study of statistics, and today we're going to focus in on the 5-number summary and box and whisker plots. So as I've told you before, mathematicians are not the most creative people in the world, so the 5-number summary is going to consist of 5 things that tell us about the numbers of the data set. So it's going to include the minimum, which in the calculator will be represented by NIN. It's going to be the first quartile, which in the calculator is represented by Q1. The median, which we found yesterday, we talked about that's a measure of center. That's denoted by MED at the calculator. The third quartile, which will be Q3 in the calculator. And finally, the maximum. And the maximum will be represented by max. So to understand some of this, we must know what the first quartile and the third quartile are. So the first quartile is simply the median or the middle of the lower half of data. So of the lower 50% of my data. Let's say I had a group of people and I put them in order from shortest to tallest. I would find my middle height, and then out of the person that was the middle height, I would find the person that is the middle of the shorter people. That would be my first quartile. For my third quartile, this is going to be the median of the upper 50% of data. So again, I go back to my people lined up from shortest to tallest. And if I find my third quartile, that is going to be the middle of the taller people. So then I can look and see that I have this box and whisker plot below. Things that are important for us, it has to have a number line. So this is very, very important. If you are ever creating a box and whisker plot and you don't have a number line that is a consistent number line, then you know that you've done something wrong. So on this box and whisker plot, I know that this down here will be my minimum. This first line here is my Q1. This bar in the middle is the median. Bar on the edge is my Q3 or my third quartile. And then finally we have our maximum. Now the thing about the median, you might notice that it's not in the middle of the box. As long as it is inside the box, that is okay. Our median can move as close to Q1 as it can. That just means that a lot of my data points are around Q1 for the median, or it can move all the way up to Q3, and that just means that I have higher values. Now, why is it called a quartile? Well, because each section here is worth 25% of the data. So everything that's divided up divides it into 25%, which is why when we say the first quartile, we start here at Q1 and we look at everything below it. This is what we call the 25th percentile. So I just want to add everything up that is below Q1. So for my third quartile, which is here, I want to add up everything that goes with it. 25 plus 25 plus 25. So that gives me the 75th percentile. So again, we're called quartiles because it divides my data into fourths. So the middle 50% of our data, and again, I'm going to look at the middle, and that is between here and here, and if I add that up, that is 50%. So the middle 50% of our data falls between the quartiles. The difference between the quartiles will give you an idea about how much of the middle of your data is spread out. So this difference is also known as the interquartile range. Because that takes so long to write, a lot of times you will just see it as IQR. And again, the way to find the IQR is to take Q3 and subtract Q1. Now, in yesterday's lesson for the intro to statistics, we talked about the shape of an object or of our distribution, and we talked about those shapes could be symmetrical, they could be skewed to the left, they could be skewed to the right. We also talked about center, and the measures of center were mean, median, and mode. Well, today we're going to talk about measures of spread. So make sure that you understand what the measures of spread are. The ones that we're going to talk about specifically today are going to be the IQR, which we just identified down here, interquartile range, which I find by taking Q3 and subtracting Q1. And the other thing is to find the range. Now, we've talked about how to find the range of graph before when we're talking about domain and range. We know that range are the y values. Well, that's of a graph. Of a data set, the range is going to simply be the maximum minus the minimum. Okay, so these two things are going to tell me about how spread out my data set really is. So how spread out the numbers are. So let's look at an example. Here we have example 1. The development of an office of a local college did a salary survey of alumni who graduated 2 years ago and have jobs. 16 alumni responded to the survey the first week. Their annual salaries in thousands of dollars are displayed below. We're going to create a box and whisker plot for the data below. So main thing we want to do here, just like yesterday when we were trying to find the mean and the median of a data set, we want to go into our calculator. So you want to hit the data button. When you hit the data button, you should see 3 columns pop up, L1, L2, and L3. Well, in L1, you want to put each of these 16 numbers, both lines here, into the calculator. So you hit 23, enter, 27, enter, 28, enter, so on. Once you get all that done, you want to hit the light blue button, and then the data button. Then you'll see a list that says stat vars, 1 var stats, 2 var stats. You want to choose 1 var stats, and then you'll hit enter 3 times. And you'll see a list that starts with n equals and then x bar equals. Well, you want to scroll all the way down until you see min, Q1, median, Q3, and max. And when you find that in the calculator, you should see that the minimum is 23, Q1 is 30, median is 34, Q3 37, and the maximum is 44. Now, one thing the calculator will not tell us is what the IQR is. But remember, IQR is Q3 minus Q1, and the calculator does tell me those 2 things. So 37 minus 30 gives me an IQR of 7. And that's just going to be important for us to practice, and we'll look at that in just a second. But as I'm getting ready to put this onto my graph, we need to have a consistent number line here. So I'm just going to start and make this go up by 2s. You can pick anything that you want on your number line as long as it's consistent. I just picked 2s because it seemed the best bet for what we'll be doing. 40, 42, 44, 46, 48, 50, 52, 54, 56. So now as I go through, my minimum is at 23, which is right here. My Q1 is at 30, so here. Median 34. Q3 is 37. I always like to stop and connect my box here for some reason. And then my max is at 44. So I just want to connect each piece. Then I have my minimum here, my Q1, my median, Q3, and my max. And I don't have to put these numbers above it because I already have my 5-number summary listed right here on my page. So as we continue through, we have something called outliers. Now, when we discuss outliers, that's going to be something that is very different than the rest of our data set. So if we're talking about outliers of people, this is somebody who acts different than the group. But again, when we're in a data set, an outlier is a data value that is significantly different, so very different, either larger or smaller than the other values in our data set. And when we have an outlier, that's going to affect the other statistics that we calculate. And specifically, that is going to affect our mean. So think about test scores. Anytime you're absent, I put a 0 in for your test score. and that is going to pull your average down. Now that's just to remind me and you that you need to make up the test. But as soon as that 0 goes into the grade book, it pulls your average down, because a 0 is an outlier. You shouldn't have a lot of tests where you scored a 0. Now on the other side of that, if I put in a 1,000 instead of 100, that's going to significantly make your average much higher, because you don't score a lot of points of 1,000. So just know that if an outlier is a low outlier, it's going to pull my average down. If the outlier is a high outlier, it's going to pull the average up. Now, the way we find an outlier is by calculating the lower fence and the upper fence. So we need a boundary here. So we have to have one for the lower side and one for the higher side. An upper fence. I like to think about this like the shock collar for dogs, where you bury the fences under the ground. You put a shock collar on a dog. If the dog gets real close to the fence line, it's okay. But the second the dog steps on the fence line and crosses over, it gets shocked. Same principle here when we talk about outliers. Now, there are two formulas that you must have in order to calculate what the outliers are. And those two formulas are Q1 minus the IQR times 1.5, and then we're going to look for any number that is that number or lower. The other part here is Q3 plus IQR times 1.5. Let's scroll back up just to make sure why we say IQR times 1.5. Back in this example, if we look, my IQR was 7. But if you look at my box length here, this was 30 to 37. So my box length is actually 7. When we find an outlier, we want to go from this box, so our third quartile, for instance, if we're finding an upper outlier, we're going to go one box length plus another half of a box length. And if any value is here or higher, we consider that an outlier. Now when we look at Q1, we want to go minus, because we want to try and get it outside of our data, a whole box length plus another half of box length, and then any number at that point or below is going to be what we consider to be an outlier. So we have these two formulas that we can run to test those values to see if they truly are an outlier. So let's look at example 2. Brenda needs to get her oil changed in her car, but she really hates to wait. So Quick Change and Speedy Oil are two garages near Brenda's house. Brenda chooses 12 customers from each garage to look at their wait times. So they want us to construct a box plot for each of the two garages near Brenda's house. So what I'm going to do is I'm going to calculate the 5-number summary for Quick Change here. So I'm going to take these 10 values, these 12 values, and put them into my calculator. So I'll hit data, put all my values in, 10 enter, 60 enter, all the way through. And then I'm going to hit second data, and then I'm going to look for my min, Q1, my median, Q3, and my max. And when I do that, I should be able to find that my minimum for Quick Change is 10, my Q1 is 15, my median is 19, Q3 would be 22.5, and then my maximum 60. While I'm here, might as well go ahead and find the IQR as well. Okay, so we'll take 22.5, and we'll go ahead and subtract 15. When we do so, we get an IQR of 7.5. I'm going to do the exact same things over here for Speedy Oil. Okay. So I'm going to go into data, put all these values in, 5, 60, 45, come back and hit second data, and then we're going to look for these values. So once you get all this into your calculator, again, you want to hit second data, go to one variable stats, hit enter 3 times, and then you're going to look for these things. So for my minimum, I should have 5. My Q1 we should get 28, median 36, Q3 50, and my max is 85. While we're here, we're also going to go ahead and find the IQR. That's going to be 50 minus 28 gives me an IQR of 22. Now, as I get ready to graph this, I'm going to put both of these box plots on the same number line. So when I pick my number line, I'm going to choose here to go up by tens. I'm going to start at 0 and just go up by 10. And I've used two different colors on purpose so that you can tell the difference between these box plots. So as I'm graphing quick change here, my minimum was 10. My Q1 was 15, so about here. Median was 19. Q3, 22.5. And again, these values don't have to be perfect because I do have my 5-number summary listed right here. And my maximum is 60. Now I'm going to come back and do the same thing with my speedy oil. In this case, my minimum is 5. My Q1 is 28. Median 36. Q3 50. And then I have a maximum of 85. So straight away I can look at these and decide which garage I would prefer to go to. And if it were me, I would prefer to go to the quick change because their times are quicker. So I'm going to go to the quick change. Because it's faster. Now, we also need to go back and find our outliers. We just discussed those, so we know we've got to run some tests here. I've already found my IQ1. So for my quick change, I'm going to take my Q1, which was 15. I'm going to subtract 1.5, remember the box and a half, times my IQR, which was 7.5. Find that value. So I'm just going to type that directly into my calculator. 15 minus 1.5 times 7.5, and I get a value of 3.75. So at this point, I just need to go back up and see, is there any values in this list for quick change that are 3.75 or lower? And I can see that there are not any in that list. So the next thing I need to do is do my upper fence. So I'll take my Q3, which was 22.5. I'm going to add that, because this is the upper side, to 1.5 times 7.5. And when I run this one, I get a value of 33.75. So as I scroll back up, I want to look in the list to see if I have any values here that are 33.75 or higher. And I can see that I do have a value of 60. So an outlier for quick change is going to be the wait time of 60. That's the one that is significantly different from the rest of the group. Now I'm going to come over and run my outlier test for speedy oil as well. So I'll take Q1, which was 28. I'm going to subtract it from 1.5. Now my IQR is 22. And type that into the calculator. So 28 minus 1.5 times 22, where I'll get a value of negative 5. Well, this doesn't make sense because these are wait times. Time can't be negative, so I don't have to worry about the lower outlier. Then I need to test my upper outlier. So my Q3 is 50. So I do 50 plus 1.5 times 22. And again, we'll put that into the calculator. So 50 plus 1.5 times 22. And that's going to give me a value of 83. So what I need to do is come back up to my list in my speedy oil and see, are there any times that are higher than 83? We'll see that there is one here, one outlier that is higher than 83, and that is the wait time of 85 minutes. So quick change had one outlier, it was 60. So does speedy oil, it was 85. So if we look at example 3, they've asked me to calculate the 5-number summary in the IQR for the 10 largest cities in Georgia, and this is being measured by in the thousands. So I'm just going to take these 10 values and I'm going to type them into my calculator. I'll hit data and then enter these 10 values. Go back second data, one variable stats. I hit enter 3 times and then I'm looking for the list. So my 5-number summary will be the minimum, Q1, the median, Q3, a maximum, and is also asked me to find the IQR. So as I do this, I can see that my minimum in this data set is 76.7. My Q1 is 88.3. My median is 104.7. Q3 is 189.9. And my maximum is 420.6. So to find my IQR, I have to take my Q3, 189.9, and subtract my Q1 of 88.3, which gives me an IQR of 101.6. And when we do that is we calculate the upper and lower fences for the outliers. When I do my lower fence of 88.3, I'm going to subtract 1.5 times 101.6. Again, it's always 1.5. It's a box and a half outside of our data. So when I type that into the calculator, I get negative 68.6. Remember, this is measuring population, so I know this isn't correct. That can't happen. So there will be no lower outlier. Then I check the upper outlier. So I take my Q3, which is 189.9. I'm going to add that to 1.5 times 101.6. It's the upper outlier, so I'm adding. It's always 1.5, so a box and a half above my data. When I do that, I get 342.3. So I'm looking at my data set. Is there any number that is 342 or higher? And there is 420. So my outlier is 420.0. Is the outlier. Well, the next thing that it's asking me to do is to create a box and whisker plot for this data. So they've given me the number line, got my 5-number summary. I'm going to go up by 50s here. Again, your number line does not have to be the exact same as mine. As long as you are consistent, you are correct. So for my minimum, we had 76.7. About right here. Minimum is Q1 is 88.3. It's about there. The median 104.7. It's about there. Q3 189.9. And again, these don't have to be exact because I have my 5-number summary and it's listed right up here. Okay. And then for my maximum, we have 420. So I can see that the outlier of 420 is going to stand out from the data a good bit. The next question they're asking me is to calculate the mean with the outliers and also to calculate the mean without the outliers. So if you go back and hit data, you should still have all these numbers in. So all you want to do is hit second data, one variable stats, and then find X bar. When you find X bar, you should find the mean for this data set to be right now 148.19. Now to calculate the mean without the outliers, all I need to do is go back and hit data. I'll highlight 420 and I'll hit delete. That takes that value out. Then I'll hit second data, one variable stats, enter 3 times, and then I'm going to look for X bar again. So if I find X bar, I should see that its value is 118.14. 0.356. It's actually 0.3555556. We're just going to go ahead and round up. So in this case, how do the outliers affect the mean? Well, the outliers raise the mean. Again, it was a higher outlier, which means it pulls the mean up. And which value is a better representation of our data? The mean with the outliers or the mean without? We know that's going to be the mean without the outliers. That's a better representation of where my data points really are. Now it's time for you to practice example number 4. You're going to have 2 box plots directly on top of each other, just like we did in example number 2.